Video 131, factoring expressions with negative or rational exponents. This first example, 36k to the negative third plus 24k to the negative 2. Now, before we actually go any further, let's take a look at a problem we already know how to do. Let's say you were asked to do 12x to the ninth plus 18x to the fifth, something like this. What we would do, the first thing we would do if we were asked to factor this. Alright, why are we doing this one? Because it doesn't have the negatives. This is a relatively easy problem. What we're going to do here is we're going to take out the greatest common factor. Okay, so the GCF. Now let's break down that phrase, greatest common factor. What we're looking for is a factor that is the greatest that the two terms have in common. So these two terms, what's the greatest factor that they have in common? Factors are numbers that can divide into another. Alright? So the greatest number that divides into 12 and 18 is 6. Okay? Then, the greatest value of an exponent that divides into x to the ninth and x to the fifth, the greatest that they have in common is x to the fifth. That's why 6x to the fifth is the greatest common factor. It's that easy. You don't need to make this more complicated than it is. So then now what we do is we use the fact that 6x to the fifth is the greatest common factor. So we're going to call this 6x to the fifth times. Now how many times does 6 go into 12? 2. X to the fifth goes in here. How many times? X to the fourth amount of times. And then this is, you're just left with a, looks like a 3. Just a 3. Because 6 goes into 18 3 times. X to the fifth goes in there just 1. So it would be 3 times 1, which is 3. And that's it. Okay? Let's use this logic over here. Now, hopefully we can see that the GCF is in fact 12 between 36 and 24. Now here is the trick. Here's the fun part of this problem. Let's go back and analyze what we know. We know that when we decided on x to the fifth, we decided on the greatest that they have in common. So what we did was we decided that the greatest that they have in common was the what? Smaller exponent. Take out the smaller exponent, right? So guess what? What's smaller? Negative 3 or negative 2? Negative 3 is definitely smaller. So we're going to take out a 12k to the negative 3. That's the logic behind it. We did the same thing here that we did over here. Same problem. Just because there's negatives in there doesn't mean you do something different. Alright? Now, we take out the 12k to the negative 3. 36 over 12 is 3. 24 over 12 is obviously 2. Now, remember what a factor is. It's a number that can divide in. So we're going to use, we're not going to put an equal sign in front of here. We're going to use these this division problem here. We're going to divide the 12k to the negative 3 into each term. Okay? That gives you a 3. That just cancels to a 1, so it's 3. This gives you 2. Now, why is this 2k? Here we'll see. Now, if you know anything about negative exponents, we know that they are trying to reciprocate the number. So this phrase here can be rewritten as 24k cubed over 12k squared. Now some of you might say, okay, well why didn't the 24 switch with the 12? Because the 24 has its own little exponent, it's a 1. Same thing with the 12. So the 24 have positive exponents. That's why they stay where they are. These two have negative exponents, so they switch spots. Well, then you can easily see 24 over 12 is 2, and k cubed over k squared is k, the first. And that's as simple as it gets. Then what you'll probably see here in the directions on this kind of problem in a pre-calc class is they're going to ask you to simplify the answer without any negative exponents. So therefore, we just move the k down here, and same principle, the 12 has a positive 1, so the 12 stays in the numerator, and you just leave the answer just like this. If some of you want to distribute, you can, but you probably don't want to do that because we were asked to what? Factor the expression. So I guess we probably wouldn't want to do, if we did distribute, I think that would just bring us right back to here. So yeah, we definitely don't want to do that. So this is the factored form of this. Now, this is not the only way to do this, but this is definitely a nice strategy in applying what you already know here to there. All right, here's the next one. You got 3r plus 1 to the negative 3 halves plus 3r plus 1 to the 1/3 plus 3r plus 1 quantity to the 4/3. we are going to use this division problem to help us simplify. Now again, hopefully you understand that the hard part would be to select the greatest common factor. And again, they all have a 3r plus 1 in common, so that's going to be a factor. The greatest that they have in common, what's the logic? You take out the smaller exponent. What's the smallest exponent? The only negative exponent, so therefore the negative 3/2 is the smallest exponent. Then you go through and divide under all three. We're going to use this division. It's not equals. We're going to use this division example here to help us simplify. Well, you put your GCF out here. All right, just like we did over here. GCF goes in front, 6x to the 5th. Then, now this is a 1. Why? Anything divided by itself is 1, right? So that goes here. Now this, how did I get this? Again, your negative exponents are going to move to the numerator when they're in the denominator, and likewise, if a negative was in the numerator, it would move to the denominator as a positive. Now, what do you do when you put these two terms together? Well, they're like terms. What do you do with the exponents? Add the exponents together. That's why we're putting a plus sign. Okay? Same thing here. Move this one to the numerator, add the exponents. Now, what we do next here, it would be obviously to get common denominators, right? And we change the 1/3 to a 2/6. 2/6 and 1/3 are the same. 3/2, well, that's the same thing as 9/6. You can multiply both by 3 and just go from there. Get common denominators, you're all set. This is obviously 11/6. This is 17/6. And this would definitely be a nice way to express the answer. This is not the only way, but you can definitely use this as a way to factor, because we were asked to factor the expression, the rational, or the expression with rational exponents. Then, of course, negative exponents are probably not allowed, so then you would move the 3r plus 1 to the denominator with a positive 3/2. So, good times. If you have any questions, send an email. Talk to you later.